Example 2.5. Determine the electrostatic potential energy of a system consisting of two charges, 7 microcoulomb and minus 2 microcoulomb, with no external field, placed at minus 9 centimeter, 0, and 9 centimeter, 0, respectively. How much work is required to separate the two charges infinitely away from each other? And the third part, suppose that the same system of charge is now placed in the external field, what would be the electrostatic energy of the configuration? So we start with the first part now. We'll see what are the given values. The charge Q1 is given, charge Q2 is given, and they are located in position x1, y1, z1, x2, y2, z2 is given. So that we can conclude the separation between these two charges is minus 9 to plus 9. So total separation is 18 centimeter, that is 0.18 meter. Okay. What is the formula for electrostatic potential energy? Potential energy U equal to K Q1 Q2 by R. Here only two charges are separated, so only one term will be there. K Q1 Q2 by R. Now we'll directly substitute the values. K value is 1 by 4 pi epsilon naught, that is 9 into 10 to the power 9. Q1 and Q2 are given here, 7 into 10 to the power minus 6. And second one, minus 2 into 10 to the power minus 6. They are separated by a distance of 0.18 meter. Now only the simplification is left here. Plus into minus. So final answer will be minus. And if you simplify, you are getting 0.7 joule. So potential energy with these two charges under the absence of external field is 0.7 joule. Why this negative sign? Negative sign shows that both the charges are attracting each other. Now we'll go for the second part. How much work is required to separate the two charges infinitely away from each other? Now they are separated by 18 centimeter. We have to keep those two charges infinitely away. Now, work required to separate the charges to infinity equal to formula is U final minus U initial. Energy at final infinity point, that is always 0. Therefore, 0 minus initial energy. Initial energy is minus 0.7 minus of minus 0.7. So you are getting answer work done is plus 0.7 joule. Now we go for the third part. Part C. Suppose that same system of charges is now placed under the external field. External field is not given directly. It is given E as A into 1 by R square, where A value is given. What would be the electrostatic energy of configuration? Previous case, what we calculated, that is due to internal electric field. Now we are going for external field. Same charge, separation remains same, but the external field is introduced here, equal to A by R square, where A value is given. Okay. Now, first you find the potential due to external field. External field, electric field is given. So, by using this, we have to find out the potential. What is the relation between electric field and potential? Electric field equal to negative of potential gradient minus dV by dr. dV by dr equal to minus of E. But E value is given as A by R square. So we'll replace E by A by R square. Now we have to integrate dV equal to minus A by R square into dr. Integrating both the side, dV integration is E. And integral of A by R square dr, it becomes A by R. How it becomes like this? See here, integral of A is constant minus outside. Integral of R to the power minus 2 dr. That is R to the power minus 2 plus 1 divided by minus 2 plus 1. Minus 2 plus 1 is minus 1. So minus 1 by R. Minus A already taken out. 1 by R square integration you are getting minus 1 by R. Therefore, if you simplify, you are getting A by R. limit is from infinity to r. After applying the limit, no change in the value because it is already r. So V external becomes A by r. After getting potential under the external field, now we'll go for values. V equal to A by R. A value is given as 9 into 10 to the power 5 divided by R. No change in the separation. That is 0.09. They are kept at the separation of 0.09. So I'm substituting 0.09. Each charge is at the separation. First one is also -9. Second one charge is at +9. Now I'm taking R1 for single charge. So 0.09. So 10 to the power 7 volt I got. Now we'll go for the work done. E value here is total energy equal to external energy equal to Q1 V1 plus Q2 V2. Q1 value is given as 7 micro and V1 we got it as 10 to the power 7. Q2 is -2 into 10 to the power -6. V2 also 10 to the power 7 because both are separated same distance with respect to the origin. So in the previous case we have found out already. Again I'll go back for that one. V value is A by R. We are substituting R is 0.09. Both are separated same distance with respect to origin. So potential remains same for both the charges. That's why directly we can substitute here. Q1, V1 also 10 to the power 7. V2 also 10 to the power 7. But Q1 and Q2 are different. Q1 is 7 micro. Q2 is -2 micro. Now we are getting the external field 70 minus 20, that is 50 joule. Now we'll go for total energy. This is only under the presence of external field. Under the presence of internal field, we already got 0.7 joule with negative sign. Therefore, total energy equal to energy due to internal plus energy due to external. Energy due to internal is -0.7. Energy due to external is 50. Therefore, 50 minus 0.7. Answer is 49.3 joule. This is the total energy due to internal as well as external field. Sign of position does not affect energy here. Okay. Sign of position, this negative and one case positive does not affect the energy